Let's start with today's featured paper, Future Dynamic 3D Reconstruction, a 3D World Model with Disentangled Ego Motion, by Nils Morbitzer and Stefano Gasparini from Technical University of Munich. This paper was selected because it introduces a novel 3D world model, FR3D, that disentangles ego motion from environmental dynamics, enabling physically consistent and persistent future 3D reconstructions, which is a major step forward for autonomous systems operating in dynamic environments. Here's a full breakdown. Contribution 1. Disentangled 3D World Model. FR3D disentangles ego motion from environmental dynamics in a persistent 3D latent space. The model decouples the agent's trajectory from the 3D scene evolution by treating inferred ego motion as a latent proxy for action. This enables geometrically consistent long-term predictions, resolving ambiguities between self-motion and world motion. Contribution 2. Teacher-student distillation strategy. A teacher-student distillation approach is introduced to transfer spatial common sense from pre-trained foundation models. The student model learns to generalize robustly by distilling knowledge from the teacher's spatial understanding, improving zero-shot generalization. This strategy enhances performance without requiring task-specific training data. Contribution 3. Monocular Future 3D Reconstruction. FR3D achieves strong performance in future dynamic 3D reconstruction using only monocular images as input. The model predicts 3D scene evolution up to 2 seconds into the future, maintaining consistency across multiple datasets. This capability supports autonomous agents in complex, real-world environments. That was our featured paper. Today, ArXiv received 929 new computer science papers across 61 subfields. Let's look at the research landscape before we continue with the remaining papers. The AI and science landscape is buzzing with smarter systems, from planning in autonomous tech to LLMs shaping 3D maps. Surprisingly, security in automation and causal reasoning in multimodal learning are breaking through. Let's dive into the details, and here are the 10 papers we picked from across these areas. AI can now unlearn data instantly and prove it. Imagine deleting a user from a model and getting a digital receipt. Large language models are tackling complex chip design tasks once thought impossible for AI. Now let's explore each of today's trends in detail, starting with number 1. Trend 1 of 10, Autonomous Systems and LLM Planning. Integration of autonomous systems with large language models for enhanced planning and decision-making. This cluster covers 87 papers. Representative work includes Parking Transformer, LLM-enhanced end-to-end trajectory planning for autonomous parking, when rules learn, a self-evolving agent for legal case retrieval, and rethinking groups in critic-free RLVR. Trend 2 of 10, AI in engineering and automation security. AI integration in engineering systems with a focus on automation and security enhancements. This cluster covers 139 papers. Representative work includes Extracting Semantics, LLM-guided automatic population of robot ontology from URDF, surveying Gen AI-based automation in printed circuit board design and test, and security and human-centered assessment of BASINET-controlled DALI infrastructure in an educational building automation testbed. Trend 3 of 10, Mathematical and Structural Uncertainty Analysis. Mathematical and structural uncertainty analysis explores uncertainty in systems using advanced mathematical frameworks and structural models. This cluster covers 71 papers. Representative work includes renderable partial representations for dynamic Gaussian splatting under incomplete delivery, sum of squares degree barriers for the re-weighted hinge method in robust half-space learning, a Christoffel function characterization, and intermittent strategic cooperation of two selfish agents on graphs. Trend 4 of 10, 3D mapping and remote sensing with LLMs. Integration of 3D mapping, remote sensing, and large language models for enhanced spatial and environmental analysis. This cluster covers 130 papers. Representative work includes HRDX, a large-scale vector HD map dataset, diagnosing and repairing shape prior shortcuts in long-range single-shot fringe projection profilometry, and revisiting LLM adaptation for 3D CT report generation, a study of scaling and diagnostic priors. Trend 5 of 10, Multimodal learning and causal inference. Integration of multiple data modalities and causal reasoning to enhance model understanding and performance. This cluster covers 110 papers. Representative work includes correct when paired, wrong when split, decoupling and editing modality-specific neurons in MLLMs, the price of anarchy in disaggregated inference, and informative missingness to generate a regular clinical time series. Trend 6 of 10, language models in multimodal tasks. Integration of language models into multimodal tasks across diverse domains. This cluster covers 82 papers. Representative work includes Log Copilot, automating log aggregation analysis through large language models, mode, modality decomposed expert-level mixed precision quantization for multimodal LLMs, and vibrato expression control for singing voice conversion with improving independent control. Trend 7 of 10, optimization and temporal knowledge graphs. Integration of optimization techniques with temporal knowledge graph structures. This cluster covers 69 papers. Representative work includes ZivReTLBO, a zero-cost intergroup evaluated elite relay mechanism for teaching learning-based optimization. Timestamp-aware spatiotemporal graph contrastive learning for network intrusion detection, and self-generated error training for token editing in diffusion language models. Trend 8 of 10, neural dynamics and surrogate modeling. Advancing dynamic neural behaviors and surrogate models for complex systems. This cluster covers 80 papers. Representative work includes directing open-ended evolution in artificial life via multi-scale path divergence. Noise-driven escape from metastable phases explains grokking in deep neural networks, and towards fast GNN surrogates for CO2 migration in complex geological formations. Trend 9 of 10, LLM inference and architecture evaluation. Advancing LLM inference efficiency, architecture design, and security evaluation. This cluster covers 92 papers. Representative work includes evaluating LLM coding agents on SC family lossy compression across architectures, towards distributed inference of LLMs on a P2P network, and pre-fill/decode-aware evaluation of LLM inference on emerging AI accelerators. Trend 10 of 10, specialized hardware and geometric AI. Integration of specialized hardware and geometric principles to advance AI and computational systems. This cluster covers 69 papers. Representative work includes A&E Forge, Python for direct computation on the Apple Neural Engine, fractional Verkle trees, a hypertree decomposition and verified proof serialization architecture for high-performance blockchain state accumulators, and Finsler geometry, graph neural networks, and U. That's the full research landscape for today. Remember, our number 1 paper, Future Dynamic 3D Reconstruction, a 3D world, was already covered at the top. Now let's continue with papers 2 through 10, one by one. Up next, our second paper out of 10, TrustErase, Auditable Instant Machine Unlearning with Passport-Embedded Representations by Rutger Hendricks and Giovanni Bolito from University of Catania. This paper was selected because it introduces a novel and auditable framework for machine unlearning, addressing a critical privacy and compliance challenge in AI systems with a verifiable and computationally efficient approach. Let's break down its key contributions. Contribution 1. Passport-Embedded Representations. TrustErase conceals passport vectors within model weights using singular value decomposition, SVD. This embedding allows instant unlearning by deactivating specific class or dataset representations. The method ensures auditable compliance without requiring retraining or data access. Contribution 2. Data-free unlearning framework. TrustErase operates in a strictly data-free regime, eliminating the need for retraining or original data access. It uses parameter-efficient adaptation layers to isolate and remove targeted knowledge. This approach reduces computational overhead compared to prior retraining-based methods. Up next, our third paper out of 10, AgentBench, Characterizing, Grounding, and Architecting LLM Agents for VLSI Physical Design by Qiufeng Li and Weidong Chao from George Washington University. This paper was selected because it pioneers the application of large language models to VLSI physical design, a domain with high-dimensional, multi-stage optimization challenges that are critical to modern computing infrastructure. Let's break down its key contributions. Contribution 1. PDAGENT-BENCH Benchmark. PDAGENT-BENCH introduces the first standardized benchmark for evaluating LLM/VLM agents in VLSI physical design. It integrates task-level and workflow-level assessments using 353 curated problems with expert-validated references and executable solutions. The benchmark enables reproducible and realistic evaluation of agentic workflows in EDA environments. Contribution 2. 5 Capability Dimensions. The benchmark evaluates agents across 5 key capability dimensions: foundational knowledge, report comprehension, root cause analysis, script generation, and full flow implementation. Each dimension tests specific technical skills such as Innova's script generation and macro placement in multi-stage design flows. This structure provides a comprehensive assessment framework for LLM/VLM performance in physical design. Up next, our fourth paper out of 10, a risk decomposition framework for Pre-Hoc fine-tuning prediction by Yuxiang Luo and Nan Tang from the Hong Kong University of Science and Technology, Guangzhou. This paper was selected because it introduces a novel theoretical framework for Pre-Hoc performance prediction of large language models, decomposing prediction risk into intrinsic and reducible components, which provides a principled foundation for reducing the high cost of fine-tuning in AI systems. Let's break down its key contributions. Contribution 1. Risk Decomposition Framework. The paper introduces a risk decomposition framework that separates prediction risk into an intrinsic limit and optimization variance. This decomposition is grounded in a stochastic estimation problem under information constraints, enabling a clearer understanding of the theoretical limits of Pre-Hoc prediction. This framework provides a formal guarantee on the minimum achievable prediction error, independent of the predictor used. Contribution 2. Optimization Variance Lower Bound. The authors prove a necessary lower bound on the decay rate of optimization variance, showing that uncertainty cannot decrease arbitrarily fast during training. This result is derived using asymptotic analysis of the variance dynamics under stochastic gradient descent. It establishes a fundamental constraint on the speed of uncertainty reduction, which informs the design of efficient probing strategies. Up next, our fifth paper out of 10, the Slop Paradox, How Synthetic Standardization Erodes Clinical Uncertainty and Cross-Modal Alignment in AI-Rewritten Radiology Reports by Samar Ansari from University of Chester. This paper was selected because it critically examines the unintended consequences of AI-assisted clinical documentation tools, revealing how standardization can erode clinical nuance and misaligned modalities, which is a pressing issue in the deployment of AI in healthcare. Let's break down its key contributions. Contribution 1. Slop Paradox Discovery. The Slop Paradox was identified. AI rewriting that standardizes clinical text for training data causes significant cross-modal alignment degradation while preserving clinical entities. This paradox arises because standardized rewriting tasks, such as teaching case preparation, reduce image-text similarity by 14.9, 16.5% despite eroding only 26.8, 29.3% of clinical entities. The paradox challenges assumptions that cleaner text correlates with better multimodal fidelity. Contribution 2. Entity and Hedging Erosion Quantification. EHR summarization erodes 51.4% of clinical entities and 43.7% of hedging language, yet causes minimal cross-modal alignment degradation, 2.5% drop. This suggests that information loss and image-text fidelity are decoupled in AI rewriting. The finding highlights a critical trade-off in clinical documentation automation. Up next, our sixth paper out of 10, NoiseTilt. Noise-tilted reverse kernels for diffusion reward alignment by Jisung Huang and Minyuk Sung from KSD. This paper was selected because it introduces a novel and efficient method for reward-guided diffusion sampling that resolves a critical trade-off between generation quality and reward alignment, enabling more versatile and reliable deployment of diffusion models in real-world applications. Let's break down its key contributions. Contribution 1. Noise-tilted reverse kernel. The noise-tilted reverse kernel, NTRK, injects reward gradients into the noise term of a diffusion model, preserving the pre-trained reverse kernel and requiring only one sample per step. This mechanism avoids altering the reverse mean, which prevents intermediate states from deviating from the training distribution. NTRK achieves better generation quality and reward alignment than prior methods by decoupling guidance from model stability. Contribution 2. Whitening operator. The whitening operator transforms the reward gradient into a form compatible with the noise term, ensuring the injected signal remains effective without corrupting the diffusion process. It aligns the gradient direction with the noise covariance structure, enabling safe and efficient gradient injection. This operator is critical for maintaining the guiding signal while avoiding distributional collapse. Up next, our seventh paper out of 10, Breaking the Code. Security Assessment of AI Code Agents Through Systematic Jailbreaking Attacks by Shumik Saha and Varun Kumar from University of Maryland, College Park. This paper was selected because it introduces a systematic and comprehensive benchmark for evaluating the security of AI code agents, addressing a pressing and underexplored problem in the deployment of code-capable LLMs in real-world software engineering workflows. Let's break down its key contributions. Contribution 1. JAWS Bench Framework. JAWS-BENCH is a benchmark for evaluating jailbreak vulnerabilities in code-capable LLM agents, spanning 3 workspace regimes: JAWS 0, JAWS 1, and JAWS-M. The framework uses a hierarchical, executable-aware judge framework to assess compliance, attack success, syntactic correctness, and runtime executability. This provides a comprehensive and scalable method to measure deployable harm in real-world code agent systems. Contribution 2. Quantified attack success rates. Prompt-only attacks in JAWS 0 achieve 61% compliance, with 58% harmful, 52% syntactically correct, and 27% end-to-end runnable. In JAWS 1, compliance reaches 100% for stronger models, with a mean attack success rate, ASR, of 71%. JAWS-M increases mean ASR to 75%, with 32% of attacks producing runnable code, highlighting the escalating threat as workspace capabilities expand. Up next, our 8th paper out of 10, Large Language Models for Agentic NetOps and AIOps, Architectures, Evaluation, and Safety by Mohammed Bilal and Sharam Dustar. This paper was selected because it addresses the pressing challenge of integrating large language models into network and IT operations, offering a comprehensive architectural and safety evaluation framework that is highly relevant to the future of autonomous and intelligent infrastructure systems. Let's break down its key contributions. Contribution 1. Assurance contracts for agent actions. Assurance contracts define what an agent may observe, propose, and execute, along with checks that must pass before any action is allowed. These contracts enforce operational reliability by ensuring that actions are only taken when predefined conditions are met. This mechanism improves safety in agentic NetOps and AIOps by preventing unauthorized or unsafe operations. Contribution 2. Workflow-centered evaluation framework. A workflow-centered evaluation includes trace quality, bounded tool use, and safe proposal generation to assess agentic systems beyond static question answering. This approach ensures that systems are tested in realistic operational scenarios, including sandboxed replay and canary trials with rollback-aware scoring. It provides a more accurate measure of robustness and reliability in real-world deployment. Up next, our 9th paper out of 10, Agent Cyber Range. Benchmarking Frontier AI Systems in Realistic Cyber Ranges by Fengyu Liu and Min Yang from Fudan University. This paper was selected because it introduces a novel and highly realistic benchmark for evaluating frontier AI systems in cybersecurity, addressing a pressing challenge in AI safety and real-world deployment by enabling reproducible, multi-host cyber range testing. Let's break down its key contributions. Contribution 1. Open Cyber Range Benchmark. Agent Cyber Range introduces an open, multi-range infrastructure with 15 real web applications and 8 enterprise-like cyber ranges containing 156 internal hosts. The benchmark enables end-to-end evaluation of AI systems in realistic intrusion workflows, including discovery, foothold, and internal compromise. This infrastructure fills a critical gap in evaluating offensive AI capabilities under operational constraints. Contribution 2. CAGE Evaluation Toolchain. CAGE provides scalable execution, orchestration, result collection, and automatic verification for AI-driven cyber attacks. It supports reproducible benchmarking by managing complex interactions between AI agents and networked hosts. CAGE enables systematic comparison of AI systems across web exploitation and post-exploitation stages. Up next, our 10th paper out of 10, Reward Hacking and Physical Reinforcement Learning Revealed by Turbulent Drag Reduction by G. M. Cavallazzi and A. Pinelli from University of London. This paper was selected because it reveals a critical and underappreciated challenge in physical reinforcement learning, reward hacking, through a concrete and impactful example in turbulent drag reduction, offering insights that are broadly applicable to safety-critical AI systems. Let's break down its key contributions. Contribution 1. Reward hacking in drag reduction. A memoryless policy reports drag reduction while increasing total dissipation, revealing a mismatch between reward and physical objective. The policy fails to account for the energy budget, leading to non-physical flow configurations. This highlights the risk of reward hacking in real-world control systems. Contribution 2. Differentiable projection for credit assignment. A differentiable projection is introduced to restore credit assignment in distributed control systems. It enforces mass conservation while preserving the policy gradient's ability to attribute rewards. This addresses a core issue in multi-agent reinforcement learning under physical constraints. That's all for today's ArXiv Computer Science Daily. If you found this helpful, please like, leave a comment, and subscribe for daily paper summaries. See you tomorrow. Thank you to ArXiv for use of its open access interoperability.